Hi teachers, this is Mike Padilla. I'm coming to you from my office at Clemson University, and I'm also coming to you as an author, one of the authors of the Pearson Interactive Science. Today I want to say a few words about new standards and how science education is changing, but then I want to lead you through an activity that I think you might find interesting and a great way to get a sense of how science education is changing. So first of all, what are the changes that we're seeing? Well, the next generation science standards, as well as the Texas TEKS, are emphasizing something I wouldn't say is new, but a new focus, let's say, in terms of inquiry. As you know, inquiry has been a very important part of science education for the last 20 or 30 years. But the new twist is trying to get students, instead of just designing an experiment, instead of giving one or two word explanations, is to really dig into the notion of collecting evidence, making sense of that evidence, and then creating an explanation that uses the evidence to argue for a point or a principle that is based in science. So let me try to give you an example of an activity that I've done for many years that I think kids find kind of interesting. This could be anywhere from kindergarten or up through high school, but I think is mostly upper elementary and middle school oriented. I call it observation inference, and with a twist of explanation at the end. So let's start. Let's say that I'm the teacher, you are the students. I have something here that I want you to make an observation about. What do you see? If you could feel it, what would it feel like? Let me think. Oh, it's not pressing in very much. It seems to be pretty solid. What about the clarity or non-clarity of the liquid that's in it? Do you see anything on the side of the bottle? That's not on the outside, that's on the inside. How about what would happen if I twisted this cap off? Hopefully this won't explode on my desktop. What do you observe? Luckily it didn't explode. What do you observe? What's going on inside of this bottle? Can you make an inference about what's inside of the bottle? Now remember, an inference isn't just a random guess. It's an educated guess based on observations. Now what would happen, do you think, if I twisted the cap on tight again? Let's see. I probably didn't give you enough wait time on that, but you can see that there's been a change. So now I have another object that you need to observe. This is, as you can read, a box of raisins. And if I open it up, we can see that we have the typical raisins, each of them small, edible, very good, nice and sweet. The issue is, if I were working with students, I'd ask them to observe, to ask them what they are, to read the label. I would have magnifiers available so that they could observe the texture of the raisins. Are they all the same? Are any of them different? And then we get to the sort of the interactive part of the lesson. What would happen if you put some of the raisins into the bottle of water that is showing these bubbles? What do you think would happen? So I'm going to open this back up. Again, I hope it doesn't boil over. It doesn't. Take the cap off. And now drop in a few of the raisins. And you see where they're at? Whoops, something's happening. So at this point, I would ask the students to describe the activity, to try to make sense out of what's going on. Again, I want them to start with observations. I want them to start with what they see and what their senses are telling them. But and not to run to inferences first. So I would have them actually write down, make a list in a group of the observations that they're making, and make sure that list is quite detailed. It's what they see, what they smell, what they hear, and using other senses, perhaps even the sense of touch. At this point, once that list is ready, I think their students are ready to go to inferences. And you know, it's very simple for students to say, well, I know what's happening. The bubbles are collecting on the raisin and they're going up and down. But don't let them get away with just making one inference. Let's have a whole series of inferences, maybe 2 or 3 or 4. And then from that, now, so once they're finished with this part, you have a list of observations, a list of inferences, now having the kids make sense out of it. And this is the new focus of both the NGSS standards and the TEKS. Having kids actually explain, beyond the one-word explanation, what's going on. So have them put together, either in writing or oral explanation, or perhaps using a video of why these raisins are going up and down. And you'll notice, by the way, they've stopped going up and down. What would happen if we swirled the bottle? Does that make a difference in the way the raisins go? Well, there goes one, just almost went up, and most of them are sitting at the bottom. Whoop, there goes one, up and down. So the point I'm trying to get at here is, if you structure a game out of observation, inference, explanation, you can take your students from very simple things, observations, what they see, hear, feel, touch, move to inferences, ask them to explain those inferences based on the evidence that's in front of them. And frankly, you might even take it another step. What would happen if we shook the bottle up and got rid of all the bubbles? Would the raisins go up and down? What would happen if we used materials other than raisins, perhaps popcorn kernels or peanuts or something of that nature? Then they can start exploring, as they test other materials, the nature of the material that allows it to collect those bubbles. So what I've tried to do today is give you a very simple activity to use the structure of observation, inference, explanation, and finally maybe some testing of different variables to get kids to move beyond just guessing or shouting out what they think is a correct answer for a science activity, and to get them really involved in the science that's in front of them. This is the focus of the new standards, the TEKS in Texas, as well as the NGSS. I think that you'll find this is the wave and the direction of the future. So thanks for listening and observing, and have a great science day. Science teaching is fun. Thank you.